Okay, this is the last 7 questions of the Algebra 1A semester exam review packet. Let's start looking at number 40. Look at the system of equations below. You have y equals mx plus b and y equals 6x plus 15. Which of the following statements are true? This question should look pretty familiar. We did this as an activator question. A, all of the statements below are true. B, if m equals 6 and b does not equal 15, then the lines are parallel and there are no solutions to the system. C, if m does not equal 6, then the lines intersect and there's one solution to the system. And then D, if m equals 6 and b equals 15, then the lines are the same and there are infinite solutions. So let's start to go through these and kind of knock them off one by one. Let's start down with D. If m equals 6 and b equals 15, well, m stands for the slope, and b stands for the y-intercept in our y equals mx plus b. If m equals 6 in this first equation here, y equals 6x, and b equals 15 plus 15, these are the same equation. So if they're the same equation, they're the same line, and they have infinite solutions to the system. So D would be true. Let's look at C. If m does not equal 6, then the lines intersect. So they're saying the slope is any number but 6. You could say that it's y equals 3x plus 15. Well, you should know that if you have different slopes, then you have one solution. And you could plug those two equations into your calculator, into your y equals, and you would see that they would intersect, and they would actually intersect on the y-axis at 15. So C is true. For B, if m equals 6 and b does not equal 15, then the lines are parallel and there are no solutions. So they have the same slope here. This will be y equals 6x, and a number other than 15, I'm going to say 10. Since they have the same slope, they are never going to intersect. So this is also true. So since B, C, and D are true, that makes our answer A. Look at the system of equations below. We have two equations and they are both in slope-intercept form. You have y equals 4/5 x plus 7 and y equals 3/4 x plus 7. But the question's asking us about the number of solutions for the system of equations. Since these are both in slope-intercept form, I have my y equals, so I'm going to set these equal to one another. And then you're going to solve for x. Subtract 7 from both sides. 4/5 x equals 3/4 x, because the 7's cancel. I'm going to subtract 3/4 x on both sides. It'll cancel on the right, leaving you with 0. 4/5 x minus 3/4 x actually equals 1/20. You can plug that in by doing parentheses divide by 5 minus parentheses 3 divided by 4. You'd get your answer. It should be a decimal. And if you hit math, enter, enter, you should be able to put it back into a fraction. So since I have 1/20 x, I'm going to multiply by the reciprocal to cancel them out. X should equal 0. If x equals 0, I need to plug that back into one of the equations. I'm going to plug it into the top. y equals 4/5 times 0 plus 7. Anything times 0 is 0, so y equals 7. My point for the solution is 0, 7. That is 1 point, so that means I have exactly one solution. So B is your answer. (42) Another system of equations. This time we're looking for the y-coordinate of the solution. I have x plus 5y equals 27 and x plus 3y equals 21. I'm going to solve this one using elimination. X plus 5y equals 27 and x plus 3y equals 21. I can't eliminate anything right off the bat, so I need to multiply one of the equations. Since both of my x's have a coefficient of 1, I'm going to multiply the second equation by -1. So give me negative x minus 3y equals negative 21. And then I'm just going to bring down that first equation. My x's will cancel. Negative 3y plus 5y is 2y. Negative 21 plus 27 is 6. I'll divide by 2, and you should get y equals 3. Y is the y-coordinate, so I don't need to go any further. I know that my answer here is B, 3. Here we have question 43. Old MacDonald has a farm with cows and goats. Each day, Old MacDonald collects 106 gallons of milk. Each cow produces 12 gallons of milk, and each goat produces 1 gallon of milk. Each day, the cows and goats eat 420 pounds of food. Cows eat 50 pounds of food, and goats eat 2 pounds of food. They are telling you what the variables are going to be used and what they are representing, so you need to make sure you use C and G. C for cows and G for goats. I have two constraints here. We have a milk constraint and a food constraint. A is asking you to write a system of equations to model the situation. Use your constraints. For the milk constraint, it says that each cow produces 12 gallons of milk. That's going to be 12C. And then I'm adding the 1G for the goats, and that's for a total of 106 gallons. Then I have my food constraint. Cows eat 50 pounds of food and goats eat 2, and that's for a total of 420 pounds. For B, we need to determine how many cows and goats Old MacDonald has. So I'm just going to solve that inequality. I'm going to rewrite them down below. I'm looking at this first inequality, and I see that the G here has a coefficient of 1. So I'm going to solve this inequality for G. I'll subtract 12C from both sides, leaving me with G equals 106 minus 12C. Since G is solved for, I'm going to plug all of this in for the G in the second equation. So 50C plus 2 times the quantity of 106 minus 12C, which equals 420. Bring down your 50C, distribute your 2 through, 212 minus 24C. I'm going to combine like terms here. 50C minus 24C is 26C plus 212 equals 420. I'll subtract 212, leaving me with 26C equals 208. Last but not least, divide by 26. C equals 8. So I know how many cows. Old MacDonald has 8 cows. But now I need to solve to find how many goats. I'm going to plug this C answer in to this part of the equation. So it'll be 12C plus G equals 106 with the 8 plugged in. Twelve times 8 is 96 plus G equals 106. Subtract 96 from both sides. G equals 10. G stands for goats. So we know how many cows and goats we have. So I'm just going to continue my answer. Old MacDonald has 8 cows and 10 goats. Make sure you're restating your answers in context to the problem. 44. Which of the following graphs represents the linear inequality? Y is greater than negative 3x plus 5. Five is my y-intercept. Negative 3 is my slope. But before I do anything else, I want to look at this inequality sign. It says it's just greater than. It's not equal to. Since it's not equal to, I'm going to automatically cross out answers A and C because those are solid lines. This means I need a dashed line. Alright, let's look at the intercepts. Y-intercepts are at 5, 1, 2, 3, 4, 5. Look at D's, 1, 2, 3, 4, 5. It says I'm going down 3, right 1. They're both decreasing. Go down 3, right 1. That works. Down 3, right 1. The lines are both drawn correctly. Looks like we need to look at the shading. This is saying that y needs to be greater than the equation. If it needs to be greater than on the y-axis, you would shade above. But you can also plug in a point just to make sure. An easy point that I like to plug in is 0, 0. I'll plug in 0 greater than negative 3 times 0 plus 5. 0 is greater than negative 3 times 0 is 0. 0 is greater than 5. But is 0 greater than 5? No, it's not. So you're going to shade away from 0, 0. So since I'm shading away from 0, 0, I'm supposed to shade on this side. So that takes B out of the equation. And you look at D, and it looks like they're shading above. So D is your answer. $45. A company makes skateboards and scooters. Skateboards cost $38 each to make, and scooters cost $47 each to make. They can make at most 1,000 total items. They can spend at most $25,000 to make all of the items. X represents the number of skateboards and Y represents the number of scooters. So this is telling you about a system of inequalities. We need to look at our constraints to find out how many inequalities we need to create. Looking at the answer choices, it gives us 2, so that also helps. So we have 2 constraints here. We have an items constraint, and we have a money constraint. Let's talk about the items first. We have X representing the number of skateboards and Y representing the number of scooters. We don't know what those numbers are, but we know that the most they can make is 1,000. So this one is just going to be X plus Y. And if it's at most, we know that it needs to be less than or equal to 1,000. Looking at the money constraint, skateboards cost $38 each. So 38 times X plus the number of scooters times the price, 47Y. And then they can spend at most, again, another at most, less than or equal to $25,000. Let's look at our answer choices. We can automatically cross off A and B because of this 85. We haven't said anything about multiplying anything by 85. C and D look like the most viable options. However, if you look at C, we have the number of items going with the money. We need to make sure we keep our constraints consistent. So if you're talking about items, keep both the left and right side with items. If you're talking about money, both the numbers need to coincide with the money. So C is not correct. The answer is D because it looks exactly like the 2 inequalities that we just came up with. #46. Lance needs to work at the Wiggly Piggly supermarket and at his family's bike shop. His parents say that he can work no more than 14 hours each week. He's fine with this as long as he makes at least $200 a week. The job at the Piggly Wiggly, or Wiggly Piggly, pays $25 per hour, and the bike shop job pays $10 per hour. Let W represent how many hours Lance works at Piggly Wiggly, and let K represent the number of hours worked at the bike shop. Writing a system of inequalities. We have 2 constraints. We have our money constraint, and we have our hour constraint. Looking at our variables and how they're defined, W talks about the number of hours he works at the Piggly Wiggly, and K is the number of hours at the bike shop. Hours constraint would just be W plus K. Since it can be no more than 14 hours, it has to be less than or equal to 14. Going on to our money constraint, he makes at the Piggly Wiggly $25 per hour, 25W, plus $10 per hour at the bike shop. But Lance needs or wants to make at least $200. So he wants to make more or equal to $200. That is your answer for 46A. 46B, graph the solution to the inequalities below. For this one, I'm going to say to find the intercepts. Finding the intercepts, I'm going to plug 0 in for W to solve for K. Don't forget on your graph, it is labeled for you very nicely. Hours worked at the Piggly Wiggly was our W. Hours worked at the bike shop was our K. I'll plug 0 in for W to solve for K. When W is 0, K is 14. Solve the other way. W plus 0 less than or equal to 14. W is less than or equal to 14, so that point is 14, 0. Let's plot those 2 points. Looking at my inequality sign here, less than or equal to, it's including all of those points that would be on the line. So it should be a nice solid line. Find the intercepts for the second inequality. Plug 0 in for W to find K. (25 times 0 is 0). (10K greater than or equal to 200). Divide by 10. Should get K is greater than or equal to 20. So my first point is 0, 20. Find the second point. We're going to solve for W this time. Plug 0 in for K. Bring down your 25W. Anything times 0 is 0. 25W is greater than or equal to 200. Divide by 25. W is greater than or equal to 8. So my second point is 8, 0. Plot our 2 points. Once again, looking at the inequality sign, this one's greater than or equal to, so it's including all the points on that line. So it's a solid line. We do need to talk about shading. Looking back at the blue line, if I plug in a point, let's say I plug in 2, 2, plug in 2, 2 to both of the equation or inequalities so we can see where we need to shade. I'll plug in 2, 2 to the W plus K. 2 plus 2 is 4, and 4 is less than or equal to 14. So I need to shade in the area with the blue. I'll plug 2, 2 into the second inequality. (25 times 2 is 50. 10 times 2 is 20. 50 plus 20 is 70. However, 70 is not greater than or equal to 200, so that does not work. So we're not going to shade down towards that point 2, 2. We're going to shade above the line. Now my solution set here is where we have both the blue and red, and that's in this area right here in purple. So that's the area that would satisfy both constraints. C, 46C. Pick one point in the viable region and show that its coordinates meet the constraints in the problem. We need to look in this purple area. I'm going to choose point 10, 2. And if I wanted to meet both constraints, I need to plug it into both inequalities. I said we'll go with point 10, 2. I'll plug that into the W plus K inequality. (10 plus 2 is 12. 12 is less than or equal to 14. Plug it into the second inequality. (25 times 10 is 250. Plus 20. 270 is also greater than 200. If I were you, I would restate the point that you plugged in and state that it is a solution and it satisfies both constraints. 47, the last question. Rhonda starts a tutoring business. She decides to charge $40 per hour for each high school student and $30 per hour for each middle school student. She wants to make at least $1,200 each month. She plans on tutoring 2 hours per month for high school students and 3 hours per month for each middle school student. She decides that she can tutor for a maximum of 90 hours per month. Let X represent the number of high school students and Y represent the number of middle school students. Once again, we need to write a system of inequalities. We have our two constraints, money and hours. The money constraint is $40 per hour for each high school student, which is X, and $30 per hour for each middle school student, which was Y, but she wants to make at least $1,200 each month. She wants to make more or equal to $1,200. The hours constraint, looking back at our variables, we're talking about number of students, but we know how many hours she'll tutor per month. So the hours would be 2x for high school plus 3y for middle school, and it's for a maximum of 90 hours. Maximum means she doesn't want to go over that, but she could be equal to it. (47b) is telling us to sketch the solution. Once again, I'm going to find the intercepts. Plug 0 in for x to find y. 2 times 0 is 0. Divide by 3. Y is less than or equal to 30, so my first point is 0, 30. Find the second intercept. Three times 0 is 0. Divide by 2, and x will be 45, so that's my second point. We can plot those 2 points, 0, 30, 45, 0. Looking at the inequality sign, less than or equal to, it includes that, or all those points, so it'll also be a straight line. I don't like that line. There we go. Let's solve for the money constraint. $40 times 0 plus 30y less than or greater than or equal to 1,200. Should divide by 30 to get y by itself. 1,200 divided by 30 is 40. So that first point would be 0, 40. Don't forget, because I plugged 0 in for x, that's my x value. Find the other intercept. 40x plus 30 times 0 greater than or equal to 1,200. 40x greater than or equal to 1,200. Divide by 40. We have x will be 30. There's our second point. We'll plot these two. 0, 40, 30, 0. And another solid line. Try that again. There we go. Still not a fan. There we go, much better. Okay. Shading, the blue line. You can pick points. But if you think back to the classwork, If ax plus by is less than or equal to 90, you are going to shade below the line. That was from classwork 11. Then looking at the money constraint, the red line, if ax plus by is greater than or equal to 1200, you're going to shade above the line. The solution set is in between where you have the blue and red colored in. So it's that purple area. The last question, C, state one viable solution and show that it fits the constraints. Viable solution needs to be in that purple shaded region. Should plug it into both inequalities to see if it works. Let's go with 0.35. That's this point right here. Plug that in. I'm going to plug it in up top here. 2 times 30 plus 3 times 5 less than or equal to 90. 2 times 30 is 60. 3 times 5 is 15. Less than or equal to 90. 60 plus 15 is 75. And 75 is less than 90. Let's plug 35 into the second inequality. 40 times 30 plus 30 times 5 is greater than or equal to 1200. 40 times 30 is 1200. 30 times 50 is 150. Add together 1200 plus 150, you get 1350, greater than or equal to 1200. That is also greater than or equal to. So our answer would be, 35 is a viable solution because it fits both constraints. And then the last question asks where they intersect. Where they're intersecting, that's where the lines are crossing. It's at this point right here. It's also where they are equal to one another. If I look in my graph, it's at 5, 10, 15, 20. At 15, 20, so I'm going to plug 15, 20 in to make sure that they are equal to 90 and equal to 1200. So if they're asking for intersections, it needs to equal whatever the number is. So I'm going to plug 2 times 15 plus 3 times 20 less than or equal to 90 into the blue constraint. 2 times 15 is 30. 3 times 20 is 60. 30 plus 60 is 90. They are equal. That works. Plug into the second inequality. 40 times 15 plus 30 times 20 greater than or equal to 1200 equals 1200. 40 times 15 is 600. 30 times 20 is 600 as well. 600 plus 600 is 1200. 1200 is equal to 1200. They are both equal to one another, so you just showed that they intersect at 1520. That is the last question of the semester A, Algebra 1A final exam review. Good luck and study hard.